Welcome to Mystery Mass, everyone. Our goal in this lab is to measure the mass of a galaxy, a real one, a spinning one, made of stars burning hydrogen at more than 7 million Kelvin. The purpose is to figure out how to measure the mass of something that you cannot put on a scale. To prove that our procedure is sound, you'll be using this kind of galaxy. The goal is to measure mass without ever once putting it on a scale. Again, you are not measuring the mass of your cell phone directly, because if you can put it on a scale, that won't work for the galaxy. Don't take any data in kilograms over the course of this lab. If it's in kilograms, it won't work for the big spinning mass of stars. What we can track in the big spinning mass of stars without putting a scale underneath is rotation. Your goal is to use your cell phone to measure rotational period. On an app using your phone's built-in gyroscope, you can also simply measure rotational period on the clock. 1, 2, 3, 4, 5. That was 5 rotations in 5 seconds. That's 2 pi r, 5 times in 5 seconds. The first thing to do is design your setup. Consider which of the setups you've seen in in-class examples and homework problems is the one you want to use. What is it that you can put your cell phone in that will be 100% certain not to yeet your cell phone across the room? What can you put the phone in that the phone will stay, it will not fall out, and you can measure the length or radius of anything you're swinging around? How are you going to want to swing it to measure the period? Horizontally, vertically, in a cone? Draw out your lab setup. Drawing first, description afterward, only where warranted. Picture's worth 1,000 words. See what the radius of the circle is going to be. Draw it out. Know what it is you need to measure. Measure whatever length and whatever angle is going to give you the radius of that circle. When that is done, you need to figure out how to spin it with a known force. Take a few minutes to decide how it is you're going to know the tension in the strap of whatever it is you're swinging your cell phone from. Be sure. Don't check out equipment until you're absolutely sure you're going to use it. First night's work is straightforward. Finish your design. Submit on campus. Make sure you know what you want. If you are one of the 6 people who checked out something today to measure force, fantastic. This is your friend. Why not make absolutely sure that nothing is going to fly off your force probe by taping the hook of your force probe to whatever it is that you are swinging? When you're sure you've measured the force with which that phone is swinging, note that forces can be in newtons or in pounds or in gin, but not in kilograms. If it's kilograms, it's not a force. Once you've measured that force and you've measured the rotational period, then you're ready for algebra. Hopefully, as part of your design, you've already made a free body diagram. If the actual experiment you performed was simpler than your design, so much the better. Make a simpler free body diagram. Identify the centripetal force. Give it a name. If you're lucky, it's exactly one force. If you're not so lucky, it's exactly one component of one force. Use the rotational period. Use the equations we worked on in class to calculate the centripetal force. Because if you know the centripetal force, and you know the speed, and you know the radius, you can solve for the mass as the last of the missing variables. Solve for, not measure. If you can measure the mass of your galaxy without ever putting your phone on a scale, then you can measure the mass of these galaxies without having to vaporize whatever scale you try to put them on. The conclusion questions ask you to apply this method to a real galaxy. What would an astronomer need to look for? You can use the practice from your homework to see how Kepler's third law tells astronomers what to look for. and how we were ready to start measuring the mass of a galaxy as early as the 16 and 1700s once we had a few numbers under our belts. The last of the conclusion questions is to check for potential problems with your procedure. This lab was originally a cookbook lab requiring all sorts of weird tubes and pipes and stoppers borrowed from the chemistry department, none of which real astronomers use. But this is how the smart physicists at the Perimeter Institute suggest that you measure mass with this paperclip and this tube. What error were they trying to steer you away from? Did you make that error? Did you know what to look for? Hint, if you were trying the absolute simplest method, if you're swinging things horizontally, like we said in class, what angle were you assuming? Did you get that angle? What about this procedure is absolutely guaranteed to ensure that angle at any cost? And if you didn't get that angle, what consequences would it have for your free body diagram? Look over the possible sources of error in your lab. You don't need to redo your lab or retake your data, but explain what might be wrong with that data. This is a formal lab report. Most people choose to do this as a video and hold up their calculations because that way they can include video footage of their setup. Otherwise, set it up like a formal lab write-up. Explain your setup in a drawing, because you'll need the drawing and your free body diagram. Include footage if you have it. Include data for the period that you measured on the clock and the period you measured on your phone. Explain how you measured the centripetal force, what equipment you used, what number it said, and from your free body diagram, go through the problem in 4 steps to find the mass and write up how this would apply to the mass of a real galaxy with Kepler's third law in your formal write-up.